Okay, good evening, everyone. So in the last class, we discussed about the NAT instance, and we created a NAT instance also, right? Because of the NAT instance, all your private subnets are able to browse the internet, and we can say that it will be able to communicate with the internet using only the outbound traffic. The NAT instance will not allow any incoming connections through the NAT. So all your private EC2 instances are getting the internet, right? They're able to access the internet. And what if we delete what we call that the NAT instance? What will happen if we delete the NAT instance? So your private instances will lose the internet connectivity, right? Okay. So for that reason, what I do is I will delete the NAT instance, and we will check whether we will get the internet after deleting the NAT instance or not. Then we can move on with the NAT gateway. So let me delete the NAT instance. Delete the NAT instance and check the internet browsing. So once we delete the NAT instance, all your private subnet instances will lose the ability to browse the internet. Then we can discuss about NAT gateway, and we will see how to create it and what are the advantages. So how to delete a NAT instance? NAT instance is nothing but an EC2 instance, right? The way how you can delete a normal regular EC2 instance, the same way you have to delete. Terminate it. Select the instance and terminate it. So log into your Amazon account and go to the EC2 service. Navigate to EC2 service and go to the instances and select your NAT instance and terminate it. The moment once you terminate the NAT instance, your private subnet machine will lose the access. So let us verify. So how to log into this private EC2 instance? Can we log into that private EC2 instance directly? No, because it doesn't have a public IP. For that, we will use an instance called Bastion host, which is a regular EC2 instance only. We will log into that Bastion host, and from here we can log. So first we need to log into the Bastion host. Let me log in. I think in the last session, we have noted down the details of the Bastion host. Let me log in. So this is the IP, public IP address. Let me enter the password. This is our Bastion host. From there, you have to log into the private EC2 instance. Yesterday we logged in, but we haven't logged out that. I will show you. This is the one. Let me show you. Wait a second. Okay. So these are the private EC2 instance details, right? Yesterday we noted down in the Bastion host. Right now I am in the Bastion host. This is the IP address of the Bastion host. Now we need to open the remote desktop connection. Enter the private IP of the private EC2 instance. Let me copy the password. Click on connect. And enter the password. So now it is connecting. And once you log in, open the browser and try to access any website, you will get page not found error, because there is no internet connection available on your private subnet, and there is no NAT instance or NAT service to share the internet. because these are the T2.micro instances. You will get a little bit a low performance because it has only one CPU and 1 GB of RAM. But for the free tier, always it is recommended to use the T2.micro only, or at least like T3.micro. Okay, so here, wait, this is the page which we opened in the last session. It seems still it is loading or something. It seems it got struck. Wait a second. Okay, let me close and reopen the browser. Since yesterday it is running, right? Because it has a very low memory. It seems something went wrong and it got struck. Okay. If you face such kind of issues, just simply you can restart the EC2 instance. Everything will be cleared up and it will give some better performance. But in the real time, we don't use such kind of a small instances. We will use some more memory and more number of CPUs. So you don't face these kind of issues in the production environment. Okay, I will do one thing. Just give me, okay, it seems it is responding. Because the CPU is at 98%. That's why the instance is not responding. Wait a second. Okay, so it seems now it is good. Let me open a browser. And let me try to access any website. Let me type rediff.com, or let us go with gmail.com. Whatever it is, that doesn't matter. Any website you can access. Okay, I think it's better to restart the EC2 instance. Give me a second. So just wait for like 2 minutes. Once it got restarted, we will log into the private EC2 instance and we can check, do we get any internet or not? But definitely we don't get any internet because there is no NAT instance to share the internet with your private subnet machines. Okay, so once it is done, we will discuss about what is a NAT gateway and why it is recommended to use over the NAT instance. Okay, right. So while creating the NAT instance, we have selected an instance type, right? So it has a limited bandwidth available. What if we have like 100 computers in the private subnet, and if they start downloading some data at a time, it will create a kind of a bottleneck where the network performance will goes down, because your EC2 instances will not automatically increase or decrease the instance sizes. That's why to avoid such kind of a challenges, Amazon provide NAT gateway. Amazon provide a service called NAT gateway, which we will discuss in some time. First, let us verify that the private instance is not able to access the internet. So this is the password. Even if you are unable to log in, just don't worry, just wait for some time, because it has to reboot it, right? As it is a Windows machine, it will take some time. Linux machines can be rebooted within 1 minute, but Windows machines will take some time. Okay, so anyways, while it is getting rebooted, let us discuss about what is a NAT gateway. So before creating the NAT gateway, we will verify that there is no internet in the private subnet, and then we can create the NAT gateway. So NAT gateway is also to provide a service called NAT, but the advantage with the NAT gateway is Amazon maintained and or Amazon managed service. The NAT gateway is highly available and highly scalable Amazon managed service. NAT gateway is also provide internet access to the private subnet instances. The difference between the NAT instance and NAT gateway is it is highly available and highly scalable. So no need to worry about like maintenance and all the things. If you consider the NAT instance, you are responsible for making that EC2 instance up and running all the time. Over a period of time, there will be some updates available, operating system updates and all the things. You are responsible to do that monthly security patching and all the things. But here the NAT gateway is Amazon managed service. We are not responsible for anything. Everything will be taken care by Amazon itself. So how can we say that it is a highly scalable is initially the NAT gateway supports 5 GB per second bandwidth. Like you can get the internet speed of 5 GB per second, and it will be increased automatically based on the usage up to 100 GB per second. Let us say if your instances are downloading a huge data, or all instances started downloading all the data, so automatically the 5 GB per second internet speed is not sufficient, then that will be increased up to 100 GB per second. That is the maximum bandwidth supported by the NAT gateway. Okay, and also it can support up to 55,000 seconds at a time, like 55,000 connections at a time. And it is having a capability of handling 1 million data packets per second. So whatever the data you download, that will be downloaded or that will be transmitted in the form of packets, right? It will support starting from 1 million data packets per second, and it will be automatically scalable up to 10 million data packets per second. NAT gateway supports 1 million data packets per second, and it will be scalable up to 10 million data packets per second. Let us say you're downloading 1 GB file. That 1 GB data will be downloaded in the form of data packets. every second, it is able to download 1 million data packets. It can handle from 1 million data packets up to 10 million data packets. And we are not responsible for maintenance of the NAT gateway. We are not responsible for NAT gateway maintenance and availability. Everything will be taken care by Amazon. And most important thing is NAT gateway is not eligible for free tier. NAT gateway is not eligible for free tier. If you create the NAT gateway, the moment you create, you are eligible for additional charges. So on what basis the NAT gateway is chargeable? Based on the number of hours we use in the sense, from the time you create the NAT gateway, it will start counting the hours. How many hours we have the NAT gateway, number of hours, and the what we call that the data transmitted using the NAT gateway. What is the meaning of data transmitted using the NAT gateway? If you are downloading some data, right? If you download 100 GB of data using the NAT gateway, then there will be some charge. If you download 1000 GB, then there will be some additional charges. So the NAT gateway charges are the combination of how many hours you are running the NAT gateway and how much data you downloaded or you uploaded. Based on that, you will be charged for the NAT gateway. Okay. So then we will create a NAT gateway, and where this NAT gateway to be created, in the public subnet or private subnet? Obviously in the public subnet, right? If you don't create the NAT gateway in the public subnet, and if you create the NAT gateway in the private subnet, the first thing is your NAT gateway will not get the internet. Without having an internet, it cannot share the internet with the private subnet. So that's why we have to create the NAT gateway in the public subnet of my first VPC. Then what we have to do? So here, instead of a NAT instance, we created a NAT gateway. So automatically your private subnet instances will start using the NAT gateway. No, how they know that there is a NAT gateway and they have to use the NAT gateway to communicate the internet? So you have to create a route like this. But instead of a NAT instance, we have to select NAT gateway because there is no NAT instance, right? That you have to do that. In which route table we have to create this? We have two route tables, right? One is a public route table and one is a private route table. Where we have to create that? Private route table, because we are providing the internet facility to the private subnet instances, and the private subnet instances is able to read the routes associated to the subnet's route table. So you have to create in this particular route table only. But there is no use of creating a route in the public route table because already there is a route for 0000 destination through the internet gateway. So the same way how you created the NAT instance route, the same way you have to create for the NAT gateway also. But in the target, instead of a NAT instance, you have to select the NAT gateway. Okay, right. So then here we will see how to do that. Then create a route in the private RT as mentioned below. So give me a second. Let me copy this. Yeah, okay. This will be the NAT gateway. In the NAT instance, we did this. And now we have to select the NAT gateway. So all the traffic will be rerouted through the NAT gateway when your private subnet instances are trying to access the internet. That is what the meaning of this particular route in the private RT. So before creating the NAT gateway, we will log into the private subnet and we will confirm that there is no internet connection. If already there is an internet connection, we don't know like what we call that, whether through the NAT gateway we are getting the internet or using different thing we are getting the internet. That's why we have to check before creating the NAT gateway. And we'll make sure that there is no internet connection available in the private subnet. Okay, so let me log into the private subnet. So private EC2 instance IP address is this one, 192.168.2.42. Let me log in. Yes. So we are logging into the private EC2 instance. And let us check the internet connection in that private EC2 instance. So then we have to open the Internet Explorer. So here I will type yahoo.com. Any website you can type, that doesn't matter. So you can see waiting for yahoo.com. After 1 minute or so, you will get page not found error because there is no internet. And easily you can see that here you can see some exclamatory symbol, right? No internet access. Okay. So now let us proceed with creation of the NAT gateway. To create the NAT gateway, first log into your Amazon account and then go to the service called VPC. Go to the VPC service. And on the left side, you can see an option called NAT gateways. And you can see there is no NAT gateway yet. Click on create NAT gateway. Give some name. I will say my first VPC dash NAT gateway. You can use any name, that doesn't matter. And in which subnet you would like to create the NAT gateway? Obviously public subnet, right? Select your public subnet of my first VPC. Then connectivity type, public or private. Public. Private is like, if you create the private, it will not allow to communicate with the internet. So there is a NAT gateway which you can create using the private, but that is not for getting the internet. That will use to communicate with other VPC, or that will be used to communicate with your office servers or something else. So you have to select the connectivity type as a public. And one more thing, I forgot to mention that the NAT gateway requires an elastic IP address. Do we have any elastic IP address in our account? We don't have any. So here you can click on allocate elastic IP, so that one elastic IP address will be allocated and that will be assigned to the newly created gateway automatically. This is the one. Then just scroll down and click on create NAT gateway. Create NAT gateway. And you can see the state as pending. After a few minutes, like it will not take more than like 1 or 2 minutes, then you can see that the state is available. And let me click on NAT gateways. State is pending. Just we need to wait till the state is available. Once it is showing as available, the NAT gateway is ready to use. Then what we have to do, what is the next step? We have to create the route in the route table. In which route table? Private route table. So click on the route tables under virtual private cloud. select your private RT, click on routes, click on edit routes, and you can see the previous route got status as a black hole. Why? We created this destination should go through this particular EC2 instance interface, but we don't have such interface exist. We deleted, right? That's why it is showing as a black hole. Remove that, click on add route, select 0000/0, the same as the NAT instance, but in the target, you have to select the NAT gateway. Click on the NAT gateway and it will show the list of NAT gateways. So here select the NAT gateway, then click on save changes. So we created the route also. Before checking the internet connection, let me go to the NAT gateways, and still the state is pending. We'll wait for like 1 more minute. And once the state is available, we will log into our private EC2 instance and we will check the internet connectivity. Okay, right. Just wait for 1 minute. Okay, you can see that the status as available, right? What is the meaning of available? It is ready to use and we can use those, what we call that particular NAT gateway. Now it is time to log into our private EC2 instance. This is the one. Let me click on refresh button. You will get the internet. So to get the internet in the private subnet, at least you have one of these two services, either a NAT instance or NAT gateway. But the NAT instance is not recommended because it has a lot of challenges and disadvantages, and we are responsible for maintaining that. That's why always it is recommended to use the NAT gateway. But remember, the NAT gateway is not a free tier service. For everything, you will be charged. So once you are done with the practical, delete it, so that you will be charged only for 1 hour. Okay, right. So are you guys clear with the NAT network address translation or any questions? Are you guys clear or any questions on this NAT? Okay. So if you guys are clear, then we can move on to the next feature available on VPC. Okay, right. Just give me a second. So now we will discuss about another feature called network access control list, which is called as NACL. Few people also call it as network ACL. All are same. Network ACL, NACL, everything is the same. Okay, so to understand that better, we have to check the VPC one more time. So what are the main components of a VPC? First, we will have a VPC like this, right? This is the VPC. And here you will have an internet gateway. And we created two subnets, right? We created two subnets. This is the one. And then what we have done, we have a route table here. Just I'm talking about a single subnet only. Later we can see, we can apply the same thing to the multiple things. This is the route table. And if, let us say this is a public one. Okay, this is a public one. And the IP address is 192.168. 1.0/24, and the VPC CIDR block is 192.168.0.0/16. This is what we created, right? And by default, you will get default route. The target should be local. And to make that particular subnet as a public, we created this additional route through the internet gateway. That means there will be a connection like this and like this. Okay, right. So let us say you are trying to create one EC2 instance here. Okay. So then here it will have a security group, and assume that this is a Windows server. Already we have the Windows server, right? And the name of that server is public EC2 instance. Okay. In the security group, while we are creating, what we have done is we open the 3389 port from anywhere. Is that right? So that from anywhere, a user can log in to the Windows machine. Generally, we have to write down like this. So the request will go through the internet gateway, and from the internet gateway, it will go to the route table, and then like this, and it will come here through the security group. It will reach the internet. That is how the traffic will go. But here you can identify one more feature called NACL. NACL is also acts as a firewall. Security group is also a firewall, right? So by seeing these two, what is the basic difference or main difference between the security group and NACL? Or how can you define, or how can you understand about the security group and NACL? Okay, so both are firewalls, but NACL act as a firewall at subnet level, whereas the security group act as a firewall at instance level. Let us say you have a house. In your house, you have 3 different rooms. If you lock the main door, nobody can enter into any of the three rooms, right? What if you open the main door? What we have to do if you open the main door? You have to secure all the 3 doors manually. But what if I lock the main door? No need to worry about the remaining 3 doors, right? In the same way, if you block something here, no need to worry about the internal things. So this is a security at the subnet level. If you restrict something at the NACL, that will never enter into the subnet. The reason why we have to use the NACL sometimes is there might be some kind of a DDoS attack is happening. Then what you have to do, you have to block that particular IP address from where you are getting on all the EC2 instances available in your subnet. But there are some challenges. Instead of that, if you block that kind of request at the NACL, with a simple step, you can protect all your servers. That is the basic difference. Both are a firewalls, NACL and security group, both are a firewalls, but there are some differences in the way how they will operate. There is a difference between the security group and NACL, the way how they will operate. The first one is NACL acts as a firewall, at subnet level. At subnet level, whereas the security group act as a firewall at instance level. But there are few other differences also. And this NACL is also Amazon managed service. Just we have to create your rules. So do we have any NACL on our VPC? Yes. Without having a NACL, there is no security group. Like without having a security group, how we don't have an EC2 instance, in the same way, without having an NACL, there is no subnet. But as of now, we never ever created any rules in the NACL, right? Why? Because whatever the NACL available by default in the VPC, it will allow all inbound and outbound traffics automatically. There will be no restrictions, and the NACL will allow all inbound and outbound traffics by default. Okay. Okay, right. So once you create the VPC, AWS will provide a default NACL which will be used by all the subnets in that VPC by default. In the default NACL, all inbound and outbound traffic is allowed. By default, there is no restrictions. I will show you that how to identify, like, let us confirm that there is no restriction. There is no restriction in the NACL by default. But if you create a new NACL, by default, all the traffic will be blocked. Default NACL is different and new NACL is different. Default NACL is the NACL which is provided by AWS by default. In that, all inbound and outbound traffic is allowed automatically. But if we create a new NACL, all inbound and outbound traffic will be denied. That means no traffic will be allowed if you create a new NACL. So what we do first is, let us observe the inbound and outbound rules in the default NACL of the VPC, my first VPC. Then we can write down the differences between the security group and NACL. Log into your Amazon account and go to VPC service. And on the left side, you can find out network ACLs under security, right? Click on that network ACLs. How many VPCs do we have? 2 VPC. You can see 2 network ACLs. And out of these 2, the first one is the NACL of my first VPC. And the second one is the default VPC NACL, right? Okay, let me click on the network ACL of my first VPC. Let me click on that. And you can see inbound rule. What is the inbound rule? Source. If the traffic is coming from anywhere, the traffic will be allowed. And what about the outbound rules? If the traffic is going to somewhere or anywhere, the traffic will be allowed. This is how a default NACL looks like. And if I click on the subnet associations, you can see which subnets are using that NACL. Which subnets are using? Both subnets. Whatever the subnets we have by default, they will use that default NACL. Going forward, we will create one new NACL and we will observe that how the new NACL looks like. By default, what traffic will be allowed. Before that, let us try to differentiate, or let us try to understand the difference between the security group and NACL. We will write down the points. Security group. And then somewhere here, I will write down the NACL. Okay. So first one is, what is the first difference? security group runs at instance level, right? Whereas the NACL runs or available at subnet level, right? And both are a firewalls, but security group is a stateless firewall, whereas the NACL is a stateful firewall. What is the difference between the stateless and stateful? What exactly? Wait, what I said? Wait a second. This is a stateful. I got confused. NACL is a stateless. Yeah. Security group is a stateful and the NACL is a stateless. What is the meaning of a stateful or a stateless? So in your EC2 instance, in the Linux machine, we hosted a website, right? And to allow the users to access the website, what we have done in the security group, we opened the 80 port, right? Okay. So let us try to understand what exactly the communication is happening. So here we have an EC2 instance in which we are running a website. And here there is a security group. So every security group, there is inbound rule and outbound rule, right? So in the inbound rule, we open 80 traffic from anywhere. Assume that in the outbound, no rule is there. We haven't opened anything. Okay. So now whenever a user is trying to access the website, the request will go to the security group. So the user will send the request on 80 port, right? Okay. So then in the inbound rule, it will check for that the 80 port is open from anywhere or not, or at least from the IP address of that particular user. If yes, that will be reachable to the web server. And then the web server, this is called as a request, right? The user is sending a request. Then there will be a response coming out from the web server, and that has to be received by the user. This is called as outbound traffic or response. So this response has to come through the security group, right? This is also called as return traffic. This is called as return traffic. In the stateful firewall, the return traffic will be automatically allowed. No need to create a separate rule to allow the return traffic. So here there is no rule, let us say. Then how it will impact the server? If you log into this server and if you open a browser and if you type google.com, then that is a request going out, right? So that has to go through the security group using the outbound rule. As there is no rule, this machine cannot communicate with the internet, but it will accept all the, it will accept all the incoming requests coming on 80 port. And the return traffic for the incoming request will be automatically allowed in the security group. That is the meaning of a stateful firewall. That is the meaning of stateful firewall. The meaning of the stateful firewall is the return traffic of any incoming request will be allowed automatically. Not required an outbound rule. It is not required an outbound rule to allow the return traffic. Whereas in the NACL is a stateful firewall. So we have to allow the return traffic explicitly. Explicitly means we have to create a separate rule to allow the return traffic. Okay. So in the previous example, The incoming request is coming on 80 port, right? Incoming request is coming on 80 port. The return traffic will go on which port? Not 80. Not 80. That depends on the operating system. Your operating system will decide on which port that response to be sent as a return response. That is called as ephemeral ports. That we will see later. That is not a AWS thing. That is a firewall rules. You go for any firewall, they will use such kind of ephemeral ports. Always the return traffic will go on ephemeral ports. That depends on the operating system. Okay. And then the security group will allow, or what we can say that we can create allow rules only. What is the meaning of that? In the security group, we can create allow rules only. You cannot create a denied rule. What is the meaning of that? Let us say if you would like to allow a traffic from anywhere, you can write like 80 port source anywhere. Let us say I would like to restrict your IP address or your home, and whoever is trying to access my website from your home, I would like to deny them. I don't want to allow a particular IP address, which is not possible in the security group. Let us cross check that. Let me go to the EC2 service, or not the EC2. Wait a second. Let me try to create a security group, and I will show you what kind of security group we can create. What are the options we can select at the time of creating the security group? If you click on the create security group, if you are adding a rule, is there anything like you can deny? No. Whatever the rule here you can write, that will be allow. There is no option to deny a specific IP address or a specific port. But whereas in the NACL supports both allow and deny rules. We can create allow and deny rules. If you would like to restrict a specific IP address not to access your Windows server using a RDP protocol, you can do that also. And also, every rule will have, and we can say that these are the numbered rules. So every rule will have a number, like 1, 2, 3, 4, 5, 6. That every rule will have a number. Okay, right. So in the security group, before allowing any request, it will process all the rules, and then the traffic will be allowed or denied. Whereas here, the rules will be executed in numbering order, like lower number to higher number. It will stop processing further rules once it found the required rule. I will explain what exactly it is. Okay, first I will explain about the security group, like how the security group rules works and all the things. So in the security group, what exactly the components we have? What are the things we have in the security group at the time of creating the security group? So let me create a security group. And while creating a rule, you have a type, right? We have a type, or I think it's better to use the notepad only so that it will be in the order. So how the security group rule looks like? The first one will be the type, right? And then the protocol, and then a port range, and then source, and then comment, right? So the first, I will create a thing called HTTP protocol. Protocol is TCP. Port range is 80. Source is anywhere. And this will be represented as like this. And then I will create one more rule like RDP, TCP, 3389. I can say anywhere, and then 0.0.0.0/0. Okay. Now, if some user is trying to access website on your server, if some user is trying to access website on your server, so then what will happen? First, the request will come to the security group. Then these are the two rules, right? So first, it will go to the rule. Let us say you are trying to access the website. What is the type of your request? HTTP request. So it is matching. Protocol is TCP, and the port is 80. And what is your IP address? Let us say your IP address is 1.2.3.4. That will be in this particular range. So the security group understand that you can allow to access the website, but it will not allow you. What it will do, it will go for the other rules also. So it will check for the type. Is your request is a RDP type? No. Then it will ignore. It will go for the other rules. If you have like 100 rules in security group, it will wait till processing of all the 100 rules, and then it will be allowed. So there will be some slight delay, right? Millisecond or microsecond delay. Whereas in the NaCl, if it found a rule, it will stop processing further rules. It will not process further rules once it found a specific rule for the request. Okay. Now what we do is, to understand it better, let us create one NaCl. Create a NaCl. Don't modify the default NaCl, because later you might not be able to understand like what changes you have done. So your subnet will mess up. Create an NaCl, and let us say I will use the name as public NaCl. I will create that NaCl exclusively for the public subnet. And a single NaCl can be used with multiple subnets also. Because by default, a single NaCl will be used with all your public subnets. Create a NaCl in my first VPC and associate public subnet with this new NaCl. And here you can write down like, don't create any rules initially. So then what will happen? Right now, you can see that I logged in to the Bastion host, right? Bastion host is in public subnet. What will happen if you use that NaCl? What will happen if you use this NaCl with your public subnet? There is no inbound rules and no outbound rules. So it will not allow any traffic, right? Because by default, all traffic will be denied in the NaCls. So automatically this connection will be disconnected. Okay, let us see that. Then we will add a new rule and we will observe how it will behave. Okay. So how to create the NaCl? Go to your VPC. Go to the VPC service and click on network ACLs under security. Click on network ACLs under security. Create network ACL. Create network ACL. Give it a name as public-NACL. You can use any name, that doesn't matter. By using this name, I can understand that this is the NACL used for public subnet. And in which VPC you would like to create this NACL? My first VPC. So from the drop down, select that and click on create network ACL. Now I would like to observe what exactly the inbound rules and outbound rules whenever you create a new NACL. But in the theory, what we discussed, by default, there will be no incoming traffic allowed and no outgoing traffic allowed, right? Okay. So if I click on that and if I click on inbound rules, what is the inbound rule? You can see the default rule. All traffic will be denied. In the outbound rules, all traffic will be denied. No inbound or outbound traffic will be allowed. Okay. If I go to the already logged in public subnet, still we are able to access. Why? Because we are not associated this public NACL with your public subnet. So how to associate? Select the NACL, go to subnet associations. Right now, no subnet is associated with this NACL. To do that, click on edit subnet associations. Click on edit subnet associations. Select the subnet which you would like to associate with the public NACL subnet. Click on save changes. The moment you click on save, you can see that the connection got lost. So you cannot see anything, right? Even if you try to log in, it will not allow any incoming request. You can see the connection has been lost. Okay, now let me close it. So now what we have to do to allow that? What we have to do to allow that particular RDP request to be allowed inside? We have to create rules. But inbound rule is not sufficient to allow the incoming traffic. You have to create an outbound traffic to allow the return response. Okay. So now what we do is create an inbound rule in the public NACL to allow the RDP request from anywhere. So every rule will have a number and lower numbered rule will execute first. Okay. So first what I do is I will show you how to create the rule. While creating the rule, we can note down all the columns. What columns we have? First column will be obviously the number, rule number, and exact column names we will write down while we are creating. Okay. So to create the inbound rule, select the NACL, click on inbound rules. So these are the columns. First one is the rule number. So first thing, like I have to write down inbound rules because NACL contains inbound and outbound rules, right? So first one is a rule number. And the second one is a type. Then the protocol, port range, source, and then allow or deny. By default, you will get a rule star, which has a lowest privilege, which has the lowest priority. Okay. So by default, you will get like this. So star type all, and 0.0.0.0/0 deny. This will be the default rules. Okay, right. So here in the inbound also, you can see all, 0.0.0.0/0 deny. Because of this, every traffic, every request will be denied by default. Now here we are going to create a rule. I will give the rule number as 100. I will give the rule number as 100. Type. So here click on edit inbound rules. Then click on add new rule. Give the rule number as 100. Type. Type should be RDP. Protocol is TCP. Port range is 3389. Source 0000, LO or deny. Okay, right. So I will use like this. What is the rule number? Type is RDP. Protocol is TCP. Port number is 3389. Source like this. We are creating like this. Which one will be executed? Because you can see the same rule, one with LO and one with deny. Which one will have the priority? So here, this will be executed first. Once it found a rule, automatically it will stop processing further rules. If I create a rule like this, whatever you can see on the screen, do you think that we are able to log into the Windows server using the RDP protocol? Do you think that? No, because the return traffic will not be allowed using the outbound rule. So first we will create this and we will check and confirm that we cannot log in. Okay, right. So here I created this. Everything is as per what we have noted down. Click on save changes. And now we are trying to log into the Bastion host, right? Okay, these are the details. MSDSC, remote desktop connection. Click on connect. You are not getting any response because your request will be received by the Windows server. And Windows server will send a response to you to enter the username and password. That response will not come through the NACL outside. So what kind of rule we have to create in the outbound rule? What kind of rule? Just you can create a separate rule with any number, that doesn't matter. So type, what type of rule? Do we need to open RDP? No. You have to open ephemeral ports. What is that ephemeral ports? So I will show you AWS ephemeral ports. Yeah, wait, ephemeral. I will show you the list of ports. So somewhere here you can see ephemeral ports. These are the ephemeral ports. So which operating system we are using? Windows 2016, right? So from Windows Server 2008 and later versions, use the port number from here to there. What is the port number? 49,152 to 65,535. The ports will be used randomly by your Windows Server. If you are using below Windows Server 2008, then the port number should be 1025 to 5000. Okay, right. So now let us add a rule in the outbound traffic. So custom TCP. I think, let me make it simple. Custom TCP protocol, TCP protocol, port range, this one, source. Sorry, here you can get not the source, here you will get the destination. Sorry for that. In the outbound rule, you can see the rule as a destination. /0, and here you have to use LO. Then your RDP will start working. because automatically it will be allowed. But in general, what we do is we will open all traffic through the outbound rule, not a specific one, because if you open the outbound rule, nobody will be able to enter, right? So that's why in the real time, we don't use this outbound rules. We will create a rule number 100 or with the lowest number. We will open all type, all protocols, all port range, all destination, allow. If you do this, your internet will not work, because if you type google.com, that request has to go through 80 port, right? Which will be restricted here. Okay, then let us see this one, ephemeral ports, and we'll confirm that the ephemeral ports will work. So where are we? So here, right? So select the NACL, click on outbound rules. All traffic is getting denied. And frankly speaking, in the real time, we don't use this NACL. Just we'll use the default NACL only. We won't restrict, but for the certification point of view, you must understand how they will work. Okay, add new rule, 100. Type will be custom TCP, port range, destination, allow, save changes. Now, if you do click on connect, you are getting this. If you got this, means the rest, you are able to communicate with the server and the server is able to send the response. Okay. Now, what I do is, what I do is, I will create another role. I will create another role, but not in the outbound role. Here in the inbound role, I will create another rule like this: RDP, TCP, 3389, and my IP address denied. What will happen? So first, let me check what is my IP address. This is the one, right? So single IP address always represented with /32. So now what will happen? Are we able to communicate with the server or not? Yes or no? Yes or no? If yes, why? If no, why? So by using this kind of a rules, we will be able to log into the Windows server at any cost, because this rule will be executed, right? I am trying to log into the Windows server using the RDP protocol. So RDP rule number 1 will be executed first, and my request is RDP, so it is matching. My protocol is TCP, again matching. I am trying to communicate on 3389. It is also matching. My IP address is in this particular source. Then my request will be allowed. Once my request got a specific rule, it will stop processing further rules. Okay, right. So let us check that. Let us create this and let us confirm that I will be able to log in even though I have a deny rule from my IP address for the RDP protocol. So let me modify the inbound rule, edit inbound rules. I will create add new rule 200 RDP. Where is the RDP? Yeah, RDP. And this /32, and here I'm doing it at deny. So even in this case also, if you click on connect, you will be able to get. And from anywhere, the users can log into our Windows server. What if I do like this? Nobody can log in. Only from this IP address we cannot log in. That means my IP address will be restricted, but everybody can log in from anywhere across the globe. This is how you can restrict a specific IP address from accessing your services or your servers. This kind of rules is not possible in the security group. Let us check this also. Let us check this also. Inbound rules. edit inbound rule. Just I will change the rule number to 50. So what will happen here? It has the priority got changed. At first, the 50 rule will be executed. So let me try. Only I cannot log in from this location. But if I go to my home, I can log in. There is no doubt in that. And anybody can log in. What if I do in this way? So here, like this. What will happen with this? Only my IP address will be allowed. Why? Okay, so first lowest numbered rule will be executed first, right? So let us say I'm logging from here, this location. So first this 50 rule will be applicable. It will process 50 rule. Yes, my request is RDP. My request is TCP. I'm trying to communicate on 3389 port, and my IP address falls into this range. And what is the one? Deny. So I cannot log in. And every IP address will fall into this only, right? So nobody can log into your Windows server using the RDP protocol. Always it will execute the first numbered rule. Okay. So in the previous example, this one, no, not this one, right? Okay. In this case, everyone can log in, right? Because it will use first. Okay. What if in this case, what will happen? In this case, who can log in and who cannot log in? Only from this particular IP address, a user can log in, and this is denied. So I cannot log in, and no other IP addresses cannot log in because there is no rule for all IP addresses. So first rule is, what if I do like this, deny and allow? Only my IP address can log in. No need to use this particular rule. No need to use this particular rule. Because if you don't mention a deny rule, obviously it will not allow any rules. So first lowest numbered rule will be executed. Let us say here, I'm using one more rule, like rule number 80. And this time I'm using HTTP, TCP, 80, and 0.0.0.0/0 and allow. And here I'm going to use 0.0.0.0/0. In this case, if someone is trying to access the website which is running on your EC2 instance, who can access and who cannot access? Who can access the website and who cannot access the website? Let us say you're trying to access the website running on the EC2 instance. Okay. So what is the request? What is the type? HTTP. What is the protocol? TCP. What is the port number you're trying to connect? 80. Okay. So first, the lowest numbered rule will be executed. So it will start processing this one. And this rule is for RDP type of a traffic. But what type of traffic you are sending? So here there is a mismatch with the rule. So this rule is not applicable for your request. Then what is the next rule? Rule number 80. It will go for the rule number 80 and type is HTTP. Yes, your request is on HTTP type and you are using the TCP protocol and you are sending the request on 80 port and your IP address falls into this range and you can access. So anybody can access. This is only for interview purpose and the certification purpose. We don't use the NACLs in the real time because which is more complicated and more complex to allow internet browsing. If you would like to allow the internet browsing, definitely you have to open all the NACL ports. Okay, right. So this is about the NaCl. Just don't mess up that. Just try to use the 3389 port and modify the rules, create multiple rules with the same rule. Or if you have some time, use Linux machine. So you can host a website and you can create different rules with 22 and 80 ports and just check how they are working. Okay, right. So if it's a website, your laptop will have one IP address and your mobile phone, mobile internet will have a different IP address, right? So you can check from two different IP addresses also. Okay, right. So this is about the NaCl. NaCl is also a firewall which operates at subnet level. Okay, right. So on this security group and NaCl, are you guys clear or any questions on this? Are you guys clear or any questions? Okay, so if you guys are clear, let us stop the session. And tomorrow we can go with VPC peering. VPC peering, by using which you can establish the communication across multiple VPCs. By default, each VPC is a different network. No two machines can communicate across two different VPCs. By using the VPC peering, you can enable the communication. That we can see in the tomorrow session and we can discuss about that. And in the meanwhile, just complete the practicals. And if you have any questions on that, you can ask me tomorrow. Because tomorrow, I guess, we will have some extra time also. The VPC peering will not take much time. We can complete within like 40 minutes or so. The remaining time, we can take up your questions. Okay? Right. And even if you have any issues while you're doing the practical, just take the screenshot of the error so that I can help you out. Okay? Okay, then. Thank you, everyone. We'll continue tomorrow.